Good morning, everybody. Thank you very much for coming. My name is Xavier Escaler. Thank you, Steven. Well, I am an industrial engineering, working now as associate professor at Polytechnical University of Catalonia in Barcelona, Spain. And I am pleased to lead this panel discussion about our work package. Together with me, we will have also as a moderator Dr. David Bermejo, on the first chair. And well, he's an aeronautical engineer who obtained his PhD in fluid mechanics with experimental research on cavitation and the effects of temperature. And now he is currently lecturer at UPC also, like me. And he is a project leader at the Barcelona Fluids and Energy Lab, which is the laboratory where we are working together. Next to him, we can see engineer Andrea Miele from ETRA. He graduated in 2019 in hydraulic engineering at University of Padova, focusing on drainage systems during his thesis. And after a short job experience in wastewater systems maintenance, he is currently working in ETRA since 2001 in the leakage detection service in Ingeniería di Processo unit under engineer Loris Pavanetto. Next to him, we can see engineer Pierpaolo Rugiero from ACQUE VERONESI. He is an environmental engineer who has worked in water utility companies for 20 years, and he is responsible for the integrated system analysis and modeling offices in ACQUE VERONESI, which is a company that manages a very large network of water distribution systems. And finally, we have Professor Eduard Doujak. He obtained his doctoral degree in mechanical engineering in 2000 from the Technical University of Vienna in Austria, and he is currently an assistant professor at the research unit of fluid flow machinery at the Institute of Energy Systems and Thermodynamics. So thank you very much to all of you for being here. So in order to introduce the discussion, I will briefly present the work we have been doing in HHOPE project. So basically, we have been dealing in this part of the research and development project on the identification of potential pilots. What does it mean? That we would like to identify the most suitable locations in current existing water distribution networks where to install our technology, the energy harvesters, under development. Okay, so basically we have in the consortium a lot of partners which are collaborating with us, together with external companies which are also providing some data. Okay, and initially the idea was try to decide together with them which could be the most interesting potential sites to install this technology, and to get data from these locations, to analyze this data and look at the suitability of the systems, and then based on this information, try to develop in the project optimal systems for these specific sites to be tested in the future. So here you can see, as Giovanna has already explained, we have a good distribution of partners around Europe. Here you can see that we have been able to collect data from pumping stations, pressure reduction valves, and district heating networks, which corresponds to the piping application. We have been able to obtain some data also from wastewater treatment plants and irrigation systems. And finally, also in rivers, and also from places like the Venice Lagoon. So it makes a total of 28 identified potential sites. And from them, finally, we have available 20 data sets. So the partners that have collaborated with us in this work is from Spain. We have Aguas de Barcelona, which is the supplier of the city. And as you can see here, they manage around 4,600 kilometers of water distribution networks. Here in Italy, we have ACQUE VERONESI with 6,000 kilometers of water distribution networks. Then in Turkey, we have another company helping us, which is ETRA SpA with a very large also water distribution network system with more than 9,000 kilometers of distribution networks and 4,000 kilometers of wastewater distribution networks. Then another company from the north of Europe in Reykjavik, they are also giving us their support with 43 kilometers of distribution network. And in this particular case, the difference with the other partners is that they have high temperatures. And then Professor Eduard will talk about it. There is another project called DIWIEN, who is collecting data from different municipalities in Europe. And we have obtained, thanks to them, data from cities in Austria and also in Czech Republic. And all this information until this point refers to water inside closed piping systems. In relation to open streams, ACQUE VERONESI has provided also some data on small channels. And then for what we call open channels, we have also the Edison Group in Italy, who is providing information about a very large channel they have to feed their hydraulic power plants with 8,000 meters length. And then in Sweden, Vattenfall company, who is a renewable energy producer, is providing us data about a river where they have interest on respecting the environmental requirements for the fishes and the species that are living there. And finally, thanks to the Consortium Energia Nuova, we have got data also on the Lagoon of Venice. So, well, you can see that there are a lot of places where we have data from. And we have also made interviews to these people to know their interests. And basically, the idea is that they are interested in installing autonomous sensors, monitoring remote locations with difficult access, and replace the sensor batteries that they have usually considering to install or they are already installing. Okay? But obviously, they have concerns that we have to face, which are the possible increase with our solutions of CAPEX and OPEX, so with increase of costs. And obviously, they would like to have endurable and resilient systems without negative effects on hydraulic fluctuations or generation of pollution. So with all this data has been processed and has been prepared. So here you have a little bit a summary of all the piping networks data. We see that the average velocity range is from almost 0 up to 3 meters per second. And we have data types of flow rates, upstream and downstream pressures, temperatures, and based on that, different rates, like every 10 minutes, every 1 minute, or different frequency rates. We have data that, for instance, 1 year of duration, several months, several days, okay? In the case of open stream and open channel, we have also some information. The average velocities in these cases are a little bit higher. They don't have 0 velocities, minimum 0.42 up to 1.53. Inside the project, we have built a database with an open source code, MySQL, which might be available to people interested in using this data for their own studies. And we have created also some tools, analysis tools, in open source code, RStudio, which could be made also available for people who is interested in this data, where we are looking basically at the time evolution of the different variables, pressures, flow velocities, flow rates, and also the histogram information of all this data, okay? And what is the conclusion? Obviously, we see that we are trying to identify flow behavior, and we see that depending on the pilot site, we have significant flow variations that sometimes they follow fixed periodicities. And we have different behavior patterns depending on the location, the type of network, and the company. So we have tried to define for the companies to analyze their networks several indicators to determine in advance which could be the most interesting locations to install the energy harvesters based on their needs, okay? So here you can see some interesting result. Here, for instance, in a drinking water supply distribution network, we can see that we have daily variations. So obviously at night, the flow rates go down, flow velocities are low. And during the day, when the consumption increases, the increase of velocity is obvious. But for instance, in another company where, for instance, in Reykjavik, where we have a heating network, in this case, the behavior is completely different. So it's almost constant along the whole day in the locations where they would like to install the energy harvesters. So every case is different and must be analyzed independently. So here you can see another observation that obviously based on this variability, we cannot find usually a single most dominant flow velocity to install the energy harvester. Depending on the flow velocity, we have different peaks here in the histogram, where we can see that the maximum number of times that we have a given velocity is very high, but for different values. And this data, we can treat it in order to get from this velocity information an indicator which is more closer to the energy, potential energy we could extract from it, which is related to the square value, the square root value of the velocity measured at a given position. And based on that, we can start to see which could be the most favorable velocity range where to design our energy harvester. But finally, obviously, there are some companies that would prefer maybe to have more continuous supply of energy, and others that would like to have maybe maximum energy. So we have developed 3 indicators to estimate the possible output power of the pilot location. One is based on time optimized capacity. The other one is based on power optimized capacity, and the other indicates the intermittency of this location. And based on these indicators, so for instance, here you can see we have selected several cases. Inside each case or company, we have different pilot sites. So thanks to these indicators, we have been able to select the most interesting or most promising locations to install HCOP technology to start testing it in the next months or years. Okay, so in summary, in this work package 3, we have identified several potential pilots, collected data, created a common database, developed visualization and analysis tools, which are in open source programs. And based on that, we have identified the flow conditions required to satisfy the customer needs based on several indicators that can be used depending on each particular case. Okay. So, well, sorry for this long introduction, but I think it was interesting for you to know what we were doing, and this can open the discussion.
Bien. So let's start with the panel discussion with a question open to all of you, okay? And based on your experience with the water networks you are working with, whether in distribution, wastewater, open channels, or streams, how would you assess the untapped potential for hidden hydropower? For example, Pierpaolo.
Good morning, everybody. I think I speak about water supply network, drinking water supply network. I think there are some possibilities in some kinds of water network with abundance of resources and low-cost resources. I think about water network fed by gravity and no by pumping plants. I think about mountain water network distribution, and in which head loss is not important. And so this kind of application, I think, give you some opportunities to produce hydropower. In general, the not balanced between operating pressure and pressure needed by customers is the key in this kind of application. But I think also that in the most cases, the problem could be resolved by efficiency, the pumping plants, by reducing the water losses, and also in reducing the drinking water consumptions. Could be a way to efficiency the water network distribution. In some cases, for example, the mountain water supply network is not important, not so important the efficiency of the network, and so that could be a very, very important power, hidden power.
Thanks. Eduard?
Yeah, I was just thinking on that. We investigated as a university in another project, more or less European project with colleagues from Czech Republic and Turkey. This one municipality in Austria, mountain municipality, so also water from the mountain down to the small village. 170 kilometers of piping. We did a lot of measurements there, and some data for the HO come from there. And I think the potential is quite high, because you have to consider not only water losses. Water losses, as we saw already before, 25% is very high. The municipality took really a lot of efforts to come down to 5% leakages. And this is one point. You have also to consider not just water losses. So we did also, let's say, technical economic analysis. It's not only water, it's also you have to treat the water by ultraviolet treatment before you can supply. So there is a lot of investment also, or let's say operational costs to treat the water, and then you lose the water. That's one point. So we found if you just detecting let's say a rupture in the piping, and you need every day, or let's say 1 week longer, this is thousands of euros. Yeah, you are losing just because you are not able to detect the leakage very easy. So it gives a strong argument to digitalize the water network, especially if you in this called section, we divided a little bit the water distribution network in sections. The first section would be from, let's say, from the spring down to a reservoir, where also other applications like pumps, turbines, and so on are already installed. We know technologies, and there are some applications there. But what is really missing is the distribution network. So where you have no pressure, more just flow velocity. But this is most of the network. So 80% is in this, let's say, low pressure, high or low velocity network, and to install there some technology like we are developing here makes totally sense. The other point we saw is during the measurements, it's not just water losses, it's also pressure hammer, yeah. Which leads directly to pipe fatigue at the end. So also it makes sense not only to investigate, let's say, water losses by pressure by 15 minutes or 1 hour. If you want to detect pressure hammer, you have to come down to sampling grades of 100 hertz or even kilohertz. Makes also sense, yeah, because this is the lifetime of the piping. And the third thing, what we also investigated by, let's say, interview of the mayor, climate change faced, he says, well, they see strong rainfalls, and within one day or even hours, they see turbidity in the drinking water. So they have to release the water and feed, let's say, the population or the inhabitants there by the reservoirs which are installed. And the reservoirs have a size of roughly, let's say, 2 days, 3 days to feed the population there with clean water. And in that time, probably let's say the water with the turbidity comes back to equality. So it would give also the chance to investigate or to measure water quality. The water quality at the moment is measured by, let's say, once a month they take a probe, a sample, and then they investigate. This is 1 probe per month. This is, in terms of heavy rainfall, nothing. Yeah. So it can also feed, let's say, if you consider also this, the health of the people with fresh drinking water, by this climate change is tremendous, I think. Then the amount of money would explode. If you can really support these leakages, let's say fatigue of the system, we saw the numbers of investment and water quality. You can just win.
Interesting point of view, Eduard. Thanks. And maybe Andrea, would you like to add your point of view on that topic?
Hello, everyone. Loris Pavanetto couldn't be here today, but I take his greetings to you. So, as Pierpaolo talked about potential water jumps in mountains and hills, I can bring another example where we have the flow available, quite constant flow available, like here between the province of Padova, Venezia, and Rovigo. We have a great adduction pipeline system called the SAVEC that should help us, should help the region to face the droughts period or pollution critical event. And so I think it could be another example of potential energy point to harvest because you have constant flow conditions available.
Okay, thanks, Andrea. To come back to Pierpaolo, I have another question. Are there any specific location in your networks where you see the greatest opportunities for implementary energy harvesting solutions, and how much untapped energy potential do you believe exists in your water network?
Okay. To this question, I can answer that in this moment we are design our district meter area, and so I think an application very interesting is to power the sensor we are planning to put in our network, because we are some problem with this sensor, because we have two choices in this moment, a battery choice which is more quickly, but have a serious impact in maintenance cost and an environmental impact, because battery is not the best choice in this optical. The other choice is to have supply by the network, the electrical network, but is not even possible, because some locations are too far from the network, and in other way is not quickly, because we have to have to ask the manager of the network and so on, the is not quickly. A solution with auto-generating power is very interesting, and so on. Also, not completely the combination of the battery and autonomous powering could be an interesting way. Another application could be with in which cases in which we have just pressure reduced valve. In some cases, we have to produce an head loss, and so could be interesting to produce also power in these cases, and maybe measuring upstream and downstream pressure of our PRV valves. Okay.
Thanks. Eduard, based on the previous discussion, and to conclude this block of questions, what do you think could be the real potential for hydropower in Europe?
In Europe.
In Europe.
In Europe. Yeah, well, I mean, we have a lot of alpine regions. We have this gravity feed of water supply. That's the one thing. But I think the technology where we are focusing on is more or less the distribution. And the distribution itself can be fed by gravity or by pumping. So the technology we are aiming, and what was discussed now, more or less this autark sensor feeding could be applied in every water distribution network. So I mean the potential is very high, and as I said before, there are other reasons than electricity production. This is more as a society or a social problem, yeah. And for that, I mean, it's hard to identify how much potential it is. I don't know any study really to identify what is the worth of water and better water and better lifetime. But I think when I saw this presentation in the morning, there will be a need of that, definitely. Yeah. And if there is a need, then the question of money, man. The potential is always
it's a big question,
always a potential and money question. Yeah, at the end it's money. But if you want to have a safe and clean water supply, you will have to invest somehow money, either by tariffs or by other sources. And I think that could help.
Okay. And regarding the application, Andrea, how can energy harvesting technologies not only generate electricity, but also play a key role in improving the digitalization of water networks?
Yes, of course, these kind of technologies could help digitalization, because digitalization needs to be distributed in the territory. But we don't have always electrical network parallel to pipe network, and so moreover, in some areas, in mountains or hills, we can have low signal to send from data loggers the data. And so these technologies could help to the capillarity of the instruments needed from digitalization.
Okay. Pierpaolo, we will appreciate any contribution on that issue, if you could, about the digitalization and how energy harvesters can contribute on that way.
In digitalization, the contribute could be to feed, to power this kind of pressure and flow sensor, which are all in Italy and in Europe need to install for monitoring our network, and also by powering the transmission device, because also this kind of device consumption energy and not very high energy, and so this could be an interesting application, and so could be a very important solution for our problem in building our network more digitalized.
Please, Xavier, would you like to add something?
Yeah, just to contribute to this discussion, I would like to share with you what I have been told from the company in Barcelona. I was in Barcelona. They are very interested in this technology, especially because they are now controlling the quality of the drinking water distribution networks very frequently and in a lot of locations, and they are advertising that on TV, that we have a very good quality of water on the radios, and they have a lot of sensors to measure the chlor content in these pipes. So they need, currently they are feeding them with batteries, but they need to put the sensors close to the locations where they have a supply, or they need an external battery, very large capacity battery that lasts for a lot of time. But obviously this requires that somebody regularly goes there to change the batteries or look at them. So they would like to increase this number of sensors to match a higher number of places. So they are quite interested on having this technology to feed sensors, basically, and to help the digitalization of the network.
Okay, thank you, Xavier. And now we would like to open the discussion for all of you, of the audience. If any of you have any questions or any comment that would like to share with us. No? Oh, okay. Here.
Good morning. Very interesting discussion. My case is my name from Tyndall. I'll be presenting shortly. We can discuss this during the break, but I'm very interested to know how obtrusive the sensors can be. So we want to put the sensors to monitor. So do we need to, do we have to drill a hole in the pipe? And, how open are you guys to do this? Or do we have to use technology whereby we monitor from the outside? It's the counter to the, you talk about a lot of stuff is in very remote locations. So, okay, you still have to go to one location once, but how easy is it then to actually retrofit and install the technology when you get there?
Well, in the case of the municipality where we measured with ultrasonic the flow rate, and pressure transducers have been installed in the pressure reduction valves. So there is most of the time a hole before and after the valve, so that's very easy to install there. But you are right. If there is no connection there, you would have to bring in some hole, to drill a hole. And that brings me a little bit to the point. Also, it's a very good aspect. If you talk to the responsible persons there in the departments of the water, let's say water department, water supply department of the municipality, their first goal is water supply. They are not energy producers. They are not digitalization guys. This is water supply. So there will be also one big topic to create awareness create awareness by these engineers, technicians being in front. And that's probably also here the idea to cut the piece of pipe and to install a very easy technology there, and then also have this measurement accessibility. But it's definitely a point, and the other point is what we heard is supply, and then of course we have to think on sensors bringing the signal to somewhere, with I don't know, any kind of remote access network or whatever. Yeah, so.
Yeah. So you have to look at the logistics, you have to look at the cost associated with retrofitting, installing this stuff, and then the life cycle savings then associated with it.
Of course. But normally you have some access to the water supply network. So what we saw, there were a lot of so-called chambers where they have closing valves, where they have this pressure reduction valves and so on. So you have at some places access, but it's not always the pressure measurement were only at the moment possible at this pressure reduction valves. We installed quite a lot of them around,
So I'm very interested to hear how, you plan to get to the stakeholders, the people who make the decision. Is somebody going to, take the upfront cost associated with retrofitting these sensors? Because there is going to be an initial cost, but there is going to be a significant saving over the lifetime.
Yeah.
So
I mean, the decision in that case, let's say the stakeholder was the mayor, so it was a municipality, and in that municipality, let's say the water costs or the cost of water demand was very low, but they have 3 dedicated or 4 dedicated persons in the water, let's say, in this department, taking care every day on the leakage and so on, but. We had a good connection to them. We went for measurement there. They helped us. But the first thing was water supply. Yeah. That has really to raise a little bit awareness in their mind that there are also additional technologies to come in the future. And also not only taking care on the waves and on the leakages and so on, but also taking care of the sensors and so on later on. Yeah.
Yeah, so my conclusion there is that we don't just need to develop the technologies, but we also need to develop the business model so we can sell it to people like this. Of course.
Without those people in, let's say, in front there in the department and these engineers, technicians, you will not succeed. Yeah, that's from my opinion.
Okay, interesting. We have time for one more question. Okay.
Hello? Works?
No.
No question.
It comes from Marcos. No.
I will try to be loud. I just have a remark, and this remark means the amount of money spent to run utilities for investments seems to me pretty low. This is, the way I'm thinking that in European Union we need stable supply of water, food. We have to have right education. These are the basic things on which our society is built. Then I see 15 and 30 and 60 euros per person. I cannot imagine how much my family spends for transportation, for cars and things like that. This is a really low number. I don't know, this cannot be, this cannot go on forever. I mean, we are now speaking about this quaternity treatment of wastewater that will treat hormones, these emerging components and microplastics and everything, but then I hear we are losing 20% of wastewater before it comes to the wastewater plant. I mean, this all needs a real big push, an injection of monies to solve this thing, I think. We have been relying on the existing infrastructure for too long, isn't it so?
Yeah, probably also in the case I was 3 years in this municipality, and we have also changed a little bit our mindset, as you said, Marco. for us, it's clear, wastewater is a service. We pay the service, yeah? In terms of fresh water that comes from the mountain, it has like, okay, this water is there, why I should pay a lot of money for a resource which is there, yeah? But what people don't think that the service has to be paid, the network has to be paid. And when I see that, 50% you don't know the age of the piping, yeah, then it's something which is unbelievable for me. We know, for example, in Austria that roughly 10% of the piping should be changed every year. Then you can come up with a lifetime of 50 years, roughly, yeah. But 10% means, in terms of 170 kilometers, which is a very small, let's say, network compared to other ones, means 70 to 20 kilometers a year should be replaced. And this is what they do is probably 1 kilometer. Yeah? So this is just infrastructure which is aging. Yeah? And this is exactly the point at the end, 50 years and later you will have to do. So we get the bill now, basically for things which have not been done in the past. And yeah.
The rate of changing pipe is 0.8.
Yeah,
I said in Italy the average substitution ratio of pipe is 0.8. So
it's totally the same, like in the municipality, because people just think, okay, I just consume the fresh water. It's not in the mindset that. And I talked to my mother. Yeah, she's living there, and she said, "Well, I should pay more for the water." I said, "Well, this is piping. Yeah, this is service." But this is also we have to change. Yeah, we are talking about technology. I know. Yeah.
Can I ask just a question about the project? Just a curiosity. If you estimate a cost for each sensor, and how long does it take to install? Also in terms of interruption of the service. I don't know. Just a curiosity. So if you estimate a cost per sensor. At the market.
Yeah, this is not computed yet because we are in the phase of development.
But just to have an idea, I know.
For piping, the idea would be you just have to cut the pipe and then weld the system. Okay. You need a linear pipe, so this could be the effort. So maybe this can be installed in one morning.
How much is the cost of the
in cost we cannot say yet. Well, maybe at the end of the project, but at the moment
developed. It's not finally developed. Yeah.
Okay.
So but I think it will be at the end when we see that there is a plate and a cylinder. It's a very low cost. There's no rotating part and things like that. That's should be normally not so expensive. Yeah, and sensor depends on the sensor quality and so on. It can go to 1,000 euros per sensor or less. Yeah, it depends a little bit.
Yeah, the good thing is that you install it and you leave it. There is no maintenance. If it doesn't break, it will work for always.
Yeah, that's if you don't have to change the battery. So. For example, I've worked with some facilities management companies and they tell me that the cost of replacing one battery is 80 euros. It's €1 for the battery and 79 euros, to get somebody to go there, find the battery, remove it, install it, reset the system and so on. So that should be taken into account as well.
Okay, so thank you so much for that interesting contribution and discussion. Thanks, Eduard, Pierpaolo, Xavier, and Andrea. Thanks.